Sometimes when you are solving a system of linear equations in two variables, you might have a situation where both of the variables are eliminated and you're left with what's considered a true statement. For example, if I give you 4x plus 3y is equal to 2 as the first equation, and then 8x plus 6y is equal to 4 as the second equation. Now let's try to solve this as usual. If we multiply, let's say I want to get rid of the x, and that if we multiply the first equation by -2, we'll see that we get a minus 8x here, which will cancel out with a positive 8x once we add them together. So let's do that. So we get minus 8x minus 6y is equal to minus 4 in the top, and the bottom equation stays exactly as it is. No change there. So now, adding them together, well, the x's cancel out, but the y's are also opposite coefficients. So minus 6y plus 6y is going to give us 0 as well. And finally, minus 4 plus 4 are also opposites, so we're going to get 0 here too. So our equation ends up turning into 0 is equal to 0. And this is what is known as a true statement. This basically means that for any x and y you choose, we're always going to end up with this true statement, which is 0 is equal to 0. Now these two equations, because this is the result, they're called dependent equations. And here's the definition. Dependent equations are what you have when both variables have been eliminated and the resulting statement is true. And as I said before, since this is the case that we have dependent equations, then as it turns out, for any x and any y, we're always going to be left with a true statement. So you want to say that there are an infinite number of solutions to the system. Because whatever set of solutions satisfies one of the equations, it's going to satisfy the other. And it's always going to lead to a true statement. So in the case of dependent equations, we know that there are an infinite number of solutions.